so today we are going to build our unit circle. The unit circle is a beautiful thing. It encompasses so much of what you have already learned and what you're going to learn and what we're going to use and all that good kind of stuff. So we're going to start on the other side, but again, you may want to go ahead and have it folded. I'll see if I can fold mine. It is ISN page 82. Okay. So ISN page 82. All right, so let's look at these triangles up here at the top. We have a 30, 60, 90 triangle. So what we know and have known for a while about this is that we can label this with S, 2S, and S times the square root of 3. Right? Then if I want to have numbers over here, I could make this 1, 2, and this the square root of 3. But if I want my hypotenuse to be 1, what would the length of the short leg be? 1/2. And then what would be the length of the long leg? 1/2. Good. So it'd be square root of 3 over 2. Okay? Does that make sense? All right. So now jump down here to these little 45, 45, 90 triangles right here. And we're going to put our little right angles on there. And this is L square root of 2. So if I want my hypotenuse of this one to be 1, then I know it may not be quite as obvious as the other one, but I do know here that L square root of 2 equals 1. So to get L by itself, I would divide by the square root of 2. 1 over the square root of 2. Laura, it's over here. I tried to call, but nobody was answering. There you go. All right, so it would be what now? Good. Square root of 2 over 2. Square root of 2 over 2. Okay. Everybody good with all that? Makes sense, right? Old business. Okay, so now I want you to take your 2 green triangles. And when you set your green triangles down, they should be reflections of each other, like so. You agree with that? Okay, because if they're not, then you don't have the right 2 triangles, or the correct 2 triangles. We're going to put little right angles on these, and on these right here. And then you're going to label the triangles. This is Roman numeral 1. This is Roman numeral 2. These are green. And then you do the same thing in here. 1 and 2. Easy enough. Then we're going to push those out of the way, and you're going to grab your 2 yellow triangles. When you put them down, they should be reflections of each other, just like on the paper right here. If not, then you don't have the correct triangles, and I want to make sure everybody has the right thing before we start. Little right angles on the triangles and on the paper. And then our Roman numerals, Roman numeral 1, Roman numeral 2. Then Roman numeral 1, Roman numeral 2. And then we can push those out of the way. Grab your 2 pink triangles. Make sure that they are reflections of each other. They should be congruent, but they're still reflections of each other. Right angles, and it should match down here. Right angles, Roman numeral 1, Roman numeral 2. Roman numeral 1, Roman numeral 2. All right. Everybody got the correct 6 triangles, yes? And they're all labeled. Okay, good. So we push those out of the way. Now open this thing up. Flatten it out. So on this unit circle here, I have given you all of the angle measures and the radian measure, or all the angle measures in degrees and in radians for all of the special angles that you are going to have to know, okay, and know all this stuff about. It's not nearly as daunting as it may seem at the beginning, okay. Understanding radians is way easier than understanding degrees because there's a lot of patterns in the radian measures where it's not so much with the degrees. I mean, the radians and the degrees both obviously keep increasing. But with the degrees, you're just having to add, and the numbers don't necessarily relate to each other. If you look at the radian measures, your denominators go 6, 4, 3, 2, 3, 4, 6, 1, and then 6, 4, 3, 2, 3, 4, 6, 1. I mean, it's the same denominators around there. There's a lot of symmetry going on in here, a lot of patterns that will make understanding all of this very, very easy. Okay, so don't be overwhelmed and be freaking out the whole time because you're eventually going to have to know all this. I'm going to baby step you through it and it's going to be fine. So let's grab your Roman numeral 1 green triangle. Okay, Roman numeral 1 green triangle. And you're going to set it down right here. So the vertex where it says 30 should be at the origin. The vertex that says 60 should be on that ordered pair. And then the side of the triangle should be on the x-axis. Should fit perfectly right there. Okay. Everybody good? So you take a little piece of tape and you're going to tape that down right there. Oh, right here. I just taped it right there. At the bottom, yes. So it's tape. It's tape. The tape is literally right underneath my finger. It's just a tiny piece of tape right there. I know you can't really see it. Maybe if I kind of. Yeah, it's clear tape. Even if I do it at an angle, you can't see it. It's just right there. And you're just taping right down over the numbers, and it's fine. You can see it now. And I was like, I don't know how to. A little reflection on there, maybe. All right. Now I want you to take this triangle and you're going to reflect it down. Okay. Now, this angle is 30 degrees, but in radians, what is that? Pi over 6. That's right there. Yeah. So it's pi over 6. So put a little right angle right here, and then we're going to relabel these sides on the back here. So this is the square root of 3 over 2. This is 1/2. And this is 1. The hypotenuse of this triangle is what part of the circle? The radius, okay? And so we want the radius to be 1. That's why this is called a unit circle, okay? Now, we could have a circle of any radius and still get the same radians and whatnot, but this is a unit circle. Our radius is 1. Now, because of how we put the tape on there, even though this fits real nicely, I can move this triangle like this and it's all wonky, right? So once you have it labeled, you want to set it back like it should go with the side on the axis, the vertex here and the vertex here, and then you're going to put another piece of tape on this side so that when you reflect it back and forth, it's going to stay correct on both sides. Okay. See how that works? Reflect it back and forth. So in addition to knowing the radian measures of the angles all the way around the circles, we also need to know the ordered pairs, which are going to be very easy to figure out as well. This 30, 60, 90 triangle, and again, 30 is actually pi 6, because we're going to start talking about everything in radians. To find the ordered pair right here, what would the x value of this ordered pair be? What do you think the x value of this ordered pair for that point is? Well, the x value, because you start at 0, you go to the right, and then you go up to get to this point, right? How far right do you have to go? Square root of 3 over 2. And then what would the y value have to be? 1/2. It comes from that special right triangle. Okay? Does that make sense to you? Now, when you reflect this down, do you see how you're actually on the angle that's 11 pi 6? What is the reference angle for 11 pi 6? Pi 6, right? Okay, now what is the ordered pair for this point right here? Square root of 3 over 2 and negative 1/2. This is why the reference angles are so important. Your reference angle for 11 pi 6 is pi 6. So the ordered pair is still these two numbers. All that's going to change is the sign depending on what quadrant you're in. Does that make sense to you? So it's not like you have to know both of these points. If you know the first quadrant, and you truly know the first quadrant, you know everything else, because this is just a reflection down. This is a graph. It's on the x and y axis, yes. Okay, so we good with that? Now what's this point right here?
That is the quadrant.
Close. What's the x value?
0. I mean, the y value is 0.
The y value is 0.
Oh, miss, I got it. It's 1.
It's 1.
Yeah.
I was hearing 0, 1 over there instead of 1, 0, but well, technically it is 1y, but it's okay. All right, so we all good so far? Not that bad, right? Okay. So now let's take your Roman numeral 1 pink triangle, and you're going to set it down right on top of the green one. Make sure the green one's flipped up. Okay. Set it down where it all matches up nicely like it should. Very nice. And then tape it down. 45 degrees is what in radians? Pi fourths. Good. Okay. For right now, you should know that obviously 0 is 0 or 2 pi. 180 is pi. So 90 is pi halves. Like that makes sense, right? Yeah. Then half of pi halves is going to have to be pi fourths, and half of 90 is 45. So at this point, knowing those, we should at least know and understand those, and we're getting to the rest. Okay? All right, so now that once I have that taped down, I'm going to reflect it down, just like I'd reflected that one. So I reflect my pink one down. Here's my right angle. This is pi fourths. Right? This length right here is the square root of 2 over 2. This is the square root of 2 over 2. This is 1. And what quadrant am I in? Fourth. I forgot to write that on the green one, but we're in the fourth quadrant. So go ahead and reflect your green one down, and let's put a 4 in the middle of that too. We're in the fourth quadrant. Bless you. We are, because see, it's already a little bit wonky, but you want to write before you tape, otherwise you're having to write over the tape and it doesn't work very well. So once you get it all labeled, then sometimes you have to like push this back up, kind of force it on there, and then just make sure that the point's there. Once you get it all where it's supposed to be, and then you can tape it down, it'll stay just fine. And you're actually taping it to the green one, which is fine. It's all going to still work fine when you reflect and all that good kind of stuff. It's quadrant 4, yes. It's quadrant 4. So when I reflect it back up and I want to get this ordered pair right here, what is my x value? Square root of 2 over 2. And the y value is square root of 2 over 2. And since they're the two sides of the triangle, that should make sense because it's an isosceles right triangle, right? So then when I reflect it down, the x value is square root of 2 over 2, and the y value is negative square root of 2 over 2. Good. All right. Now grab your Roman numeral 1 yellow triangle and make sure both of the green and the pink are both up in the first quadrant. Then you're going to set the yellow one down right on top of them and put it in its correct position. And then tape it down. And 60 degrees is what in radians? Pi over 3. Okay? So pi fourths being half of pi halves should make sense, right? Then we have 30 and 60, which are our other special angles. One of them's pi thirds and one of them's pi sixths. Pi sixths is 30 and pi thirds is 60. Okay? So they both have a 3 and a 6? Not that big of a deal. All right? Pi thirds, 60 degrees. Pi fourths, 45. Pi sixths, 30 degrees. Okay? And if we can get those down, if we can truly, truly get the first quadrant, we're going to be golden. Okay? Yes. All right. So then we're going to take this and we're going to reflect it down. Do the same kind of thing. Relabel. That's a right angle. This is pi thirds. This is 1/2. Square root of 3 over 2. 1, and we are in quadrant 4. Okay. Then once you get it all labeled, then fix the triangle and tape it. Then when we reflect it back up into the first quadrant, the x value for this ordered pair is what? 1/2. And the y value is square root of 3 over 2. Then when I reflect it down, I get 1/2 and negative square root of 3 over 2. Okay. So then I'm going to reflect it back up into the first quadrant. Now what is this ordered pair right here? 0, 1. Okay. So this completes the first quadrant, just this part up here, right? So the 1, 0, 0, 1, those are kind of no-brainers, right? We say them backwards sometimes, but we really know what they are. It's really not that big of a deal. So the 3 ones that we really have to learn or know are these 3. You notice how they're all over 2? All of them. None of them are over 3, over 4, over 5, just all over 2. So they're all fractions of halves. Then look at these 2. They have the same numbers, it's just that x and y switch places, because 30 and 60 switch places. Does that make sense to you? So overall, there's not even that many numbers you need to know. Make sense? So square root of 2 over 2, square root of 2 over 2. When they're the same, it's the square root of 2. Then the square root of 3 over 2, or 1/2, are these 2. And I'm going to give you a way, just like now that you know SOHCAHTOA, are you ever going to set up a right triangle wrong again? No, not unless you have a brain fart. I mean, but you understand how to do it, right? So there's things that go along with this that I'm going to give to you a little bit at a time. I can't do it all at once. It's way too much information. That will help you remember these things, okay? Very good. Very good. And I'm about to connect all that too, so that's good. I'm glad that you remember that. All right, so everybody good so far? All right, so now I want you to grab your Roman numeral 2 green triangle. In theory, it would be great if we could just have 3 triangles, because what I want to do now is take this triangle and reflect it over the y-axis, but you know, it's kind of hard to do to tape down the vertex. It just wouldn't stay. So this is the reflection of that triangle. Okay, but we're going to just have an actual triangle there. So we put that down where it goes and tape it down. $30 degrees is pi 6. He should be here. This is a bad day to miss. Really bad day to miss. Yeah, I know. It's probably the only day's absent. All right, so I'm going to take this, and we're going to reflect it down. All right, and then this is pi 6. This is the square root of 3 over 2, right angle, 1/2, 1. And what quadrant are we in? Third. So then once you have it all labeled, fix it back where it's not wonky so you can tape it down. And some of those tape dispensers, even though these are fairly new, some of them don't tear the tape very well. I don't really understand why they don't work. Okay.
Oh, you said you're on tape too, so.
All right. So now notice my Roman numeral 1 and Roman numeral 2 triangles are just reflections of each other. These points right here are just reflections of each other. The ordered pairs still have an x value that has a square root of 3 over 2 in it and a y value that's 1/2. But the x is negative because we're in quadrant 2. So it's negative square root of 3 over 2, positive 1/2. Then when I reflect it down to 7 pi 6, where my reference angle for 7 pi 6 would be pi 6, right? And then the ordered pairs are the same. Square root of 3 over 2 and 1/2. Which one's negative? Both of them, because we are in quadrant 3. So before we go any farther, notice that the pi 6 angle, reference angles, they're all the pi 6 angles are the ones that are closest to the x-axis. These 2 triangles, like this one reflects over here, then it reflects down, and this reflects down. These 4 points right here, do you see how the ordered pairs have the same numbers in them? All that changes is a sign depending on what quadrant you're in. Okay? It's not. It's not like 4 crazy different points that you have to just remember. These 4 ordered pairs have the same numbers in them, and you should know what in which quadrant what's positive and negative anyway. I mean, you've known that forever. That's not a big deal. Okay? So now let's grab our Roman numeral 2 pink triangle. Place it down in quadrant 2. That's why we put a Roman numeral 2 in it, if you haven't figured that out. I know. Put a piece of tape. We'll reflect it down and relabel just like the rest of them. Square root of 2 over 2. Square root of 2 over 2. Pi fourths. It's okay. It doesn't have to be perfect little squares of tape. But it would be nice, sure. All right, so this is a pi fourths angle, reference angle, right? Since it's from the 45, 45, 90, the x and y values are the same. Square root of 2 over 2. Square root of 2 over 2. We are in the second quadrant, so x is negative. When I reflect it down, pi fourths is my reference angle, so I get square root of 2 over 2 and square root of 2 over 2. I'm in quadrant 3, so they're both negative. That's why I want to build this. So I'm not just going to give it to you and tell you about it. If you see how it works and how it gets put together, you're going to understand it better in the long run. Yeah. I thought we've considered starting, because it is so important, we've considered starting the school year with that so that we could drill you on it until we actually use it, because it is that important. We just haven't actually made that happen. Did y'all actually use it at all or just learn it? Yeah. And that was probably why, though, because they want you to, because if you don't know it, you're going to struggle with everything else. Yes, we're getting there. We're getting there. So do you know it already?
So you can go ahead and teach the class.
Mm-hmm. Very good. Yes. Yeah, you want to teach more? No, I'm just kidding. All right, so let's take this yellow triangle here and put it, our last triangle down on here.
What did you say?
We're going to reflect this down.
Oh.
Okay.
It's like saying water, yeah. Not all water.
All right. So we get all that labeled and get that taped down. And then we reflect this up. And this is pi thirds. So this is going to give me negative 1/2 square root of 3 over 2. And then down in the third quadrant, I'm going to get negative 1/2 negative square root of 3 over 2. Oh, I am not going there with y'all again. We've already been down that road. All right. All right, so this ordered pair right here, what is it? What is this? Negative 1, 0. What is this? 0, negative 1. Now, stop it with the water. Now, when you look over here and you just look at this big picture, do you see all of the reflections happening with the points as well? Not just the triangles, but the points as well. All right? And knowing the first quadrant will get you everything else. Okay? And now, 45 is pi fourths. 60 is pi thirds, and 30 is pi sixths, right? The 6 is in the 3 switch. Okay. All right, so now, here's what I want you to do. We're going to take your ID so that you have a little straight edge. And you are going to place it over here up against your green triangle so that you can try and make it perpendicular. And you're going to draw a line segment from this point down to the x-axis so that it is perpendicular, like so. Okay. So basically we're drawing in a triangle here. This angle right here is theta. Technically, yes, I know it's pi 6, but we're just going to talk about it as theta. Let's say that we don't even know what the actual angle measure is. Now, on the top left of your paper, I want you to write sine theta. And sine theta from SOHCAHTOA is what over what? Oh, Lord. Opposite over hypotenuse. Yes? All right, so once I look at theta here, if I'm going to have opposite over hypotenuse, the opposite side here actually represents the y value of the ordered pair. Does that make sense? And the hypotenuse is what part of the circle? The radius. It is the radius. This is the y value, this is the radius. So sine is opposite over hypotenuse. It is also y over the radius. Now, because we have the unit circle here, in this specific circle, what is the radius? 1. So this is equal to y over 1, which means that sine theta equals y. So the reason Michael said, hey, these are the same numbers we were using when we were doing cosecant and sine, and when we started looking at that earlier, because if you come back over here now, and I say, what is the sine of pi sixth? The sine of pi sixth is 1/2. Okay? The sine of pi sixth is 1/2. The sine of pi fourths is the square root of 2 over 2. The sine of pi thirds is the square root of 3 over 2. Make sense? Okay. Oh, yeah, no. Bottom left over here. Everything you've done is algebra 1. Okay. We can have that discussion later. Right now we need to talk about the unit circle. But thanks. I do not trash the 8th grade teachers. I have never, no I haven't. I have never done that.
Yeah, you did.
No, I didn't.
Yeah, your 8th grade teacher should have taught you.
Well, that's not trashing them. If they didn't teach you that, it's not my fault. That's what you were supposed to do in 8th grade. I can't help that. All right.
So if we didn't even learn stuff that we had to reteach.
Yeah.
Anyway.
All right. Cosine theta. From SOHCAHTOA, what's that? Adjacent over hypotenuse. Okay. Adjacent over hypotenuse. So if I go back over here, the adjacent side is actually the x value, right? Hypotenuse is still the radius. So cosine is x over r, because sometimes the radius isn't 1. But in this case, it is 1, so it's x over 1. So when you have a unit circle, cosine theta is equal to x. So your ordered pairs, x, y, that we just filled in, give you the cosine and the sine value for every single one of those angles. So in the bottom right, I want you to write down cosine theta, sine theta. And how do you remember what order they go in? X, Y is alphabetical, so is cosine and sine. Cosine comes before sine in the alphabet. It's going to come before sine in an ordered pair. Okay? Everybody okay with that? All right. So now, if you look up here and I say, okay, well, for pi thirds, right, the cosine of pi thirds is 1/2. The sine of pi thirds is the square root of 3 over 2. That's why these ordered pairs are so important for us. It just tells us those values. It's not buttons you're pushing on the calculator. It's all in exact form. And it's things that you're going to have to know. But again, I'm going to get you there. Right now we're just looking at the unit circle. I'll give you those little mnemonics and that kind of stuff. Okay? All right, so then we're going to have tangent theta. Okay. Then tangent theta from SOHCAHTOA is what? Opposite over adjacent. Right? So we already figured out that our opposite is the sine of theta, or your y value, right? So tangent theta is equal to y over the adjacent side, which is x, which is also cosine theta, right? So this is sine theta, this is cosine theta. This is y, this is x. That means that tangent theta is sine theta over cosine theta. Okay. Everybody with me so far? Okay. So now you're going to take your ID badge again. You put it down on the x-axis here. Oh, shut up. And then put it on this point right here. And this time, instead of going from the point on the circle, you're going from here, and you're just going to draw a line up here so that you get a ray that is perpendicular. If you make your ID perpendicular to the axis, it's easy just to get that ray right there. And then you're going to connect this radius through that point and just like extend that radius so that it connects to that line right there. And you're going to draw probably right through one of your numbers, and it's fine. Okay. All right, so do you see when I drew in this first perpendicular line here how I made this triangle, right? Then by drawing that in, do you see how I have a bigger triangle right there and they overlap? See the two overlapping right triangles? Okay. Are those two overlapping right triangles similar? Yes. By what? How do you know? Same angles, right? So understanding that triangles are similar by angle is still an important thing. All that stuff from geometry, still important, okay? It's going to be important for you even in calculus to recognize that, oh, those triangles are similar by angle, because these two angles are congruent and they share this angle, so they have to be similar. If they're similar, I can set up a proportion, right? This side length right here, I don't have anything to call it, so I'm going to put a point A here and a point B here, so I can call this side length AB. Does that make sense? So to set up a proportion, I'm going to put sine over cosine. So I'm going to have sine theta over cosine theta equals, and then this side length, so sine corresponds to AB over this whole side length. What's the length of that side of the big triangle? 1. So sine over cosine equals AB over 1. Do y'all agree with that? So what does sine over cosine equal? Tangent. Sine over cosine equals tangent, which means the length of AB is the tangent of theta. So this is tangent theta. Okay, so that's tangent theta AB. Now take your ID and that ray that you drew, extend it so that it actually makes a line. So line AB is a line that intersects the circle at exactly what point? At one point. What kind of line is that? Tangent. This is why the tangent is called tangent. Ding, ding, ding. Okay? You see how that works? Okay, so that's why a tangent line is called a tangent line. Not something I could explain to you in geometry, because that would have just confused you and blown your mind. But because when we talked about it, we hadn't talked about trig yet anyway. So, but do you see that? That's why it's called a tangent line. That's your little tangent segment there. Okay, we good? All right. So now let's talk about a few more things that go along with this. You don't have to write this stuff down. You just need to stay with me as I walk you through it right now. We'll do some more together later on. But just looking at your circle, tell me, what is the sine of 3 pi fourths? No, you can look at it. No, you can look at it. Yeah, sorry. No, I'm not quizzing you like that yet. Don't freak out. The sine of 3 pi fourths is going to be square root of 2 over 2. Okay? What is the cosine of 4 pi thirds? Negative 1/2. 4 pi thirds negative 1/2. Okay, so do you see how to get that from the ordered pairs? All right, and then eventually when you actually learn them, and again, I will step you through that. I don't expect you to go home and memorize all this right now. That might work for some people. It's not going to work for most of you, so I don't want you going and stressing out over that and wasting your time. We're going to focus first on the first quadrant, and then we're going to get there, and it'll make a whole lot more sense. Now, since we're going to talk about tangent. I want the tangent, and I'm going to write stuff down. You don't necessarily have to write it down. You just stay with me. I want the tangent of pi thirds. Okay? Tangent of pi thirds. So the tangent of pi thirds, tangent is sine over cosine, right? So I would take the square root of 3 over 2 and divide by 1/2. Make sense? So then when I do that, that means that's the square root of 3 over 2 times 2 over 1. So I just get the square root of 3. Okay, so the tangent of this, which again, I'll explain to you how you just know that as well. But if you don't know it, you can figure it out from sine and cosine, right? What about the tangent of pi fourths? 1. A monkey over a monkey is a monkey. The tangent of pi fourths is the square root of 2 over 2 over the square root of 2 over 2. So anything over itself, you just get 1.
A monkey over a monkey is 1, not a monkey.
No, well, because it's sine over cosine. Okay, y over x. That makes sense? Okay. All right, so then when I want the tangent of pi sixths, well, I could go and I could figure all that out and do the same thing I did here. But when I do that, aren't I just going to end up with 1/2 over the square root of 3 over 2? So isn't it just the reciprocal of this one? So it's the reciprocal of the square root of 3, which is 1 over the square root of 3, which is what? Square root of 3 over 3. Okay. Does that make sense to you? So right now, being able to come up with them and understand how to get them is good, okay? But then you don't want to have to figure them out every time, so we'll talk about how you know what they are. There's not a whole lot of room on here to write all the tangent values, so I don't want to overwhelm this piece of paper. We're going to do it on another piece of paper once we don't have so much extra stuff on there. But this gets you started at least on the big picture of the unit circle, okay? Are we good? All right, good deal. So you can go ahead and tape that in. You don't have any homework today. All I want you to do is look at this unit circle, get at least the radian measures of the first quadrant in your mind. Make sure you understand how to figure those out, and then I'll piece it together a little bit at a time over the next few days.